Dr. Rebecca North, and I'm an assistant professor of water quality in the School of Natural Resources at the University of Missouri in Columbia. And I am the PI, or the principal investigator, of the EPA sponsored program called SLAP, Statewide Lake Assessment Program.
So I'm Haley Steinke. This summer I participated in SLAP, which is the Statewide Lake Assessment Program.
My name is Crystal Ryan. I've been working in the Limnology lab since 2020 here at the University of Missouri, and I took part in the SLAP program during the summer of 2020-2021.
SLAP is, it's basically two people go out in the Missouri wilderness to various lakes around the state, and they collect water samples and then filter them in a hotel room.
Me and a partner, Chris, went and sampled, I think, 50, 60 lakes over the span of 3-week intervals. So we went on a northwest route, a southwest route, and a southeast route.
So we would go out in a canoe and we would try to locate the deepest spot, which in Missouri, most of the lakes are all man-made. So the deepest spot would be right in front of the dam, which is like a flat spot in the lake. And we'd take a little, it looks like a little flashlight, but you stick it in the water and then it gives you an approximate depth of what it is.
Like it's 15, then it's 16, then it's 14.
And once you find the deep spot, you anchor there and you begin the sampling process.
There's a lot of things that we're looking for. We'd look for cyanobacteria, we'd look at the water turbidity, and we'd look at the stratification of the water, so based on like where the thermocline is at and how that varies throughout the summer. But there's a lot of different things they'll search for. They'll search for nitrogen and phosphorus and all of those different levels, including like oxygen levels throughout the water column.
It was every 3 weeks we would sample the same lake. So it'd be 2 weeks in between each one. You would go to, and you would try to find the same exact spot to sample it as well.
The thing is that we go to the same location on the lakes and sample the same thing every year, 4 times a year. And so a lot of other states are more reactionary. So if someone calls and says the water looks really green, I'm concerned it might be toxins, then they would, state agencies would run out and take samples. But we're there when the lake's not green. And so being able to kind of have that consistently sampled things, we can look at, kind of parameters that might contribute to having toxins present or that type of thing. So from a cyanotoxin monitoring perspective, we're very unique in that it's part of the monitoring program. So there's lots of states like Florida and other places that do a lot of monitoring for like nutrients and chlorophyll, but having also that cyanotoxin data associated with every sample we collect is a unique thing. And again, across 80 reservoirs every summer, 4 times for 40 years. So it's a really nice, valuable historical long-term data set.
And we can compare trends that were happening 40 years ago as to what is happening now. So being able to have that data set is not only impactful for writing papers and kind of management practices moving forward and what we're doing with our land use practices and how we can move forward in a way that's sustainable and actually improves water quality, or if we're going to continue to do the same sort of practices that we've been involved in. So it really is moving forward how we have power behind our science. So being able to show that 40-year data set is huge for us.
Especially on the north route, there's a lot more fertilizer runoff and things that happen because there's a lot more agriculture up north. So you'd see a lot more of those like algal blooms and like the shiny shimmery on top, and that's a sign that the water is struggling or has like a cyanobacteria bloom.
So the PIs of the lab at the Limnology lab here at MU will tell you that impairment, the leading cause is through excess nutrient loading. So that can be through phosphorus loading, nitrogen loading. There's all sorts of anthropogenic, that's a fancy word for man-made causes that impact those water bodies. So really focusing on the cause of that phosphorus and nitrogen, what's causing that, and then trying our best to have management practices that meet those sources. So there's non-point source pollution as well as point source. The non-point sources, which are kind of the mysteries of where all those nutrients are coming from, is what we're really trying to tackle, especially in my research in atmospheric phosphorus deposition.
So there's external nutrient loading, so what's coming in from the watershed, and that's all the land use on the watershed. But then what happens is once those nutrients are loaded in, so historically over decades and decades and decades, when they get in the lake, if they're not used by the algae, then they sink to the bottom of the lake. And so then what we're seeing is as we have these declines in oxygen, we're having changes in redox. So the phosphorus or the nutrients that were loaded in from agricultural land use and other things used to kind of safely be tucked away in the sediments and tightly bound to compounds like iron and things. So they didn't come back up into the lake where phytoplankton can use them. But now we're seeing more changes in oxygen and changes in redox, and so we're seeing internal nutrient loading. So legacy impacts. So, decades after those nutrients came in from the watershed, they're coming back up out from the bottom of the lake, the danger in the deep, so to speak. And then that can come up into the top of the water column where the phytoplankton live, and that can also lead to eutrophication and algal blooms. We're kind of in this continuous reciprocal loop, unfortunately. And so finding ways to kind of, the answer is always to do things on the landscape, but you do have to think ahead, right? So efforts we're doing now to minimize nutrient input to lakes, could help us, 30, 40 years down the road if we don't see those exact results today.
There is not a single silver bullet to identify where impairment for our waterways is coming from. We can absolutely identify excessive nutrient loading as definitely one of those bullets, but it's not the one thing that's affecting, whether it be impervious surfaces, whether it be pesticides, whether it be microplastics now, something, heavy metals in the mining belt down in the Tri-State Mining District. There are all these things that compound and add on to these habitats, and we're asking so much of these waterways to the solution to pollution is dilution. We used to hear that all the time. Well, you can only dilute something so much. And what we need to really focus on is what steps are we taking now to improve water quality, and having that bank of data really allows us to think hard about how we want to progress in the future and how we can save these water bodies before they become even further impaired.
And so these are quantitative values, mostly chlorophyll concentrations, that says if a lake's chlorophyll concentration is higher than that threshold value, then it's considered impaired. And if it's considered impaired, then it goes through this TMDL development, so total maximum daily load. So then MDNR has to basically look at all the point sources, so all the pipes that are going into the lake that might serve as sources of nutrients, and then kind of by difference looking at non-point sources. And then what can we do to try to minimize the phosphorus or cause lower chlorophyll concentrations in the lake. And so from a regulatory standpoint, that is what the data is used for. From a research standpoint, we also use that data to look at long-term impacts. So for example, last year I used the SLAP dataset where we go out and we take a YSI or a sonde and we measure temperature and oxygen with depth. So we kind of anchor in the middle of the lake and then we take kind of 1 meter increments all the way down to the bottom of the lake. And so again, having a 40-year data set, we're allowed to look at big questions like climate change. And so I contributed this to part of a GLION, the Global Lake Observatory Network, where we take kind of sampling like this that's happening all over the world, because we might see things changing in Missouri reservoirs, but is it happening everywhere? And if it is happening everywhere all the time, then it's likely linked to a big factor like climate change. And so we put it together with, I want to say 200 other different lakes around the world, spanning, from African lakes up to Arctic lakes, and found that when we're looking at these profiles over time, the bottom waters, so we call that the hypolimnium, or the part that's separated from the atmosphere, are showing lower oxygen concentrations over time. So the bottom of our lakes all over the world are having significantly less oxygen in them than they used to. And so that has huge consequences for things that like to breathe. So for fish, biomass, reproduction, macroinvertebrates, like things that live below in those sediments and stuff like that need to have that oxygen. We're getting more and more dead zones or anoxic areas around the world. So being able to take these, this little Missouri data set, which is so robust and thorough, and being able to put it in perspective of literally lakes all over the world kind of is a very powerful way to communicate that data. So we also have, kind of the research angle and use of the data as well.
One of my favorite things about the SLAP program is you drive up to these reservoirs or these lakes all across the state of Missouri, and you have you hugged a limnologist today as a bumper sticker? And everyone's like, what's a limnologist? Where are you coming from? We tell them we're from the University of Missouri and explain what limnology is, because all the time I'm like, oh, I'm a limnologist. And they're like, a lim what? And I'm like, just imagine oceanography, but lakes and rivers. And they're like, oh, got it, but being able to educate the community of these folks who have no idea that water quality measures are happening on their lakes, like that's so huge. And being able to share our passion and why we do what we do with them is huge. So just being able to educate folks about their water quality, what happens when they are adding fertilizers to their lawn per se, or methods, easy things that we can do to protect our water bodies in the state of Missouri. That to me, I think, is such a huge impact for the SLAP program.